All right, guys, very exciting times today. We are doing a 2-sample t-test, so flip in your notes packet. We are doing a 2-sample t-test, and here is the prompt. We have a study at UCLA, and researchers are wanting to compare information on students how they take notes, basically. Are you a paper and pencil type of person, or are you a laptop person? Okay, so they have conducted an experiment. They have this many volunteers, okay, not randomly selected, and that is fine. But they did randomly assign them to one of two groups. They said 109 people are like, sure, I'll play the game, whatever. You can study my note-taking skills, and they get randomly assigned into one of two different groups. And one of the variables they measured, it says, was the number of words written. And we have 55 students that were assigned to writing notes, paper and pencil. And we have their mean number of words and their standard deviation number of words. So that is fantastic for them. And then we have the other 54 students were assigned to laptop. And we have a mean and a standard deviation for them. So, do these data provide convincing evidence? Here is our clue that we are doing a test. Do you see that, friends and family? If it said estimate the difference, we would do an interval. Okay, keep in mind that this chapter combines intervals and tests, and you need to know which thing to do based on the wording of the question. When it asks you about evidence, that's when you do test. If it asks you to estimate the difference, let me just flip up here for a second. Estimate, ding, 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 there it is. There was our interval. Okay, that's what you have to do when you're asked to estimate something. Okay, great, excellent, here we go. Do we have evidence of a difference? And this does not lead me to believe that like the laptop people take more notes or that the writing people take more notes. It doesn't say anything like that. It just says, is there a difference? That is our keyword that we're doing a two-sided test. That means that our alternate hypothesis will have a not equal sign between the mean number of words, blah, blah, blah. Okay, here we are given a bunch of stats. Notice how in this problem up here, we were also given a bunch of statistics. You were given mean and standard deviation. Here we are given the actual data. See how we had to like crunch the numbers ourselves in our calculator and come up with the X bar? That determines what you hit when you go to the calculator part, whether you're going to tell it I have the stats or I have the data. So here we have the stats because we have the mean and the standard deviation already. Okay, what we're going to do is we're going to define some stuff. I am doing X sub P as the number of words written, pencil, and paper. Get it? P. Yeah, you can use 1s and 2s if you want, but you might as well choose a letter that like actually makes sense. And then X sub L is the number of words written on a laptop. Get it? And we are doing a 2-sample t-test because we have 2 different samples. They're not actually samples, they're 2 different experimental groups. And we don't have a standard deviation for the entire population, just our 109 volunteers. So that is why we're doing a T. And it says convincing evidence, which is why I'm doing a test. Okay. Now let's talk about conditions, because as you know, and as you've learned throughout this chapter, when you do an experiment, the wording changes slightly for some of the conditions here. So let's look at random. What is random about this problem? We did not randomly select people. We had a bunch of volunteers. What happened to them? They were randomly assigned. So be specific about what is random about the problem. We've randomly assigned 109 volunteers to 2 groups, either pencil and paper or laptop. And I have that defined up here, what my little subscripts stand for. Okay, so my work's very clear and very organized. For the independent condition, usually we test the 10% condition, but these people were volunteers. They were not randomly selected. So all we have to say here is we have to make sure that our experimental groups are independent from each other. That means that the pencil paper note takers are not having any sort of impact whatsoever on the laptop note takers. Okay, and I made a note to myself here that we did not take a random sample because we have volunteers. That impacts our random condition and our independent condition a little bit. Let's talk about normality. You have 3 options when you're doing a means problem. Get it? These are all whole numbers, not proportions. Excuse me. This is a means problem. So for normal condition, we have 3 different choices. Number 1, does it say anything about any distributions being approximately normal up here? No, it does not. Number 2, can we maybe apply the CLT? Oh, we have 2 different sample sizes or 2 different experimental group sizes. Yes, we can apply the CLT here because both of our sample sizes, the ends, the 55 and the 54, are both bigger than 30. CLT applies. That we are safe to use T, my friends. All right, the ho and the ha. We have to use mu's because we are trying to analyze something about the entire population, and the symbol we use for the entire population, not just the sample, but the whole population, is mu. So I'm going to define my mu of P, or mu sub P for the paper pencil, and the mu sub laptop is equal to 0 when I do the difference. Remember, for the ho, you guys, we always assume no difference. We assume they're the same. That means that if you subtract them, the difference is 0. And yes, another way of writing this is mu P equal to mu L. You could write that if you wanted to. It's a little bit less writing. And we talked already about how the wording up here gives us a 2-sided test. That means the mu P minus mu L is not equal to 0 because I do not have any inclination about one being greater than or worse than the other. Here's our formula from the formula sheet, and it is a T for a test statistic. Remember, we use Z's for proportions. We use T's for means when we don't know the sigma for the entire population, which we don't. So let's talk about plugging in the number, or the statistics here, the symbols. This is the X bar of all of the P's, which we are given up here. The paper pencil had a mean of 390. This number goes right there. And I also need the sample mean for the laptop people, which was this many. That's what goes there. That is my statistic. It's the difference in the two things that we're measuring, okay? The parameter is the number from the ho, the assumption. We are assuming no difference, so that is what goes right there. And the standard error of the statistic, it now says error on the formula sheet, so you can change that word to error. Don't let that confuse you. Let me show you the formula sheet, actually. Let me go to it real fast. We are on our 2 sample situation for means, and we only have S sub X's. We do not have sigmas. So I'm using this down here. We take the standard deviation for the first group, which is the paper pencil group, and square it and divide by the n for the paper pencil group. And then we add the standard deviation for the laptop group and square it and divide by the n for the laptop group. Okay, so I'm getting that here. It says means, and we're doing 2 populations. Our 2 different experimental groups are considered 2 populations. And we have sigmas, or we have S sub X is not sigmas, so we're using that formula. That's where I grabbed this down here, and so now you can see what it looks like with all my numbers plugged in. I took my first X bar for paper pencil, this number, and I took my X bar for laptop, that goes here, and then you can see all my other numbers plugged in. That gives me a test statistic of negative 4.002. You can type this into your home screen, or you can, in the calculator, go to 2 sample t-test, and it will ask you, do you have the stats or do you have the data? Here, up here, we have the X bar and the S sub X, that's the stats. And then it'll give you a bunch of boxes for you to type those into. Remember what it looks like if you're given the data, that means you have the actual numbers from the problem, and then you can just tell your calculator to use list 1 and list 2. That's the difference between those, okay? So anyway, can you imagine typing in a TCDF of something less than negative 4 standard deviations? Think about like what negative 4 standard deviations looks like on a bell curve. Shaded area is going to be very, very, very small. And here's what my calculator gave me. It gave me a very, very, very small number, but please don't forget to show the work for doubling it because we have a 2-sided test here. But when you double basically 0, you still get basically 0. So yes, the rubrics and on the test and everything, they will be looking to see, to make sure that you remembered to double the p-value because this only means the left tail, okay? So remember what a t-distribution looks like. Let me actually like sketch this real quick. We are like 4 standard deviations to the left, so like way over here, 1, 2, 3, 4, and we are shading this direction, which is very, very, very small. But because we have a 2-sided test, we need this tail and this one over here. So you do need to double that p-value, okay? Anyways, the p-value is basically 0. Is that p too low? Yes, the p is too low. That means that the hose got to go. Where'd my pointer go? That means that we are in favor of this. So we need to write what the ha says in words. Okay, writing the conclusion is the exact same as it was last chapter. You say, since the p-value is basically 0, you can put the actual decimal if you want, but I think it's easier to just say, well, duh, I know it's basically 0 because we're more than 4 standard deviations out. Anyways, we reject the null. And when you reject, you are in favor of the alternate, and then you restate the alternate, that there is a difference, a significant difference, okay? It doesn't say which one is better. We have not been able to determine that, but all we're saying here when we reject this and we are in favor of this is that there is a significant difference, statistically, between the laptop people and the paper and pencil people, okay? So now I need you guys to try the next example and get it checked by one of us. Thanks for listening and for playing, and let us know if you have any questions. Oh, one thing I forgot to mention. I wanted to just make sure that you remembered from last chapter, what do you do in the degrees of freedom if your these aren't really samples, but our two populations are different numbers, you use the smaller one, okay? So make a note about that and make sure your group members are comfortable with that. If you have two different sized groups or two different sized samples, you always use the smaller one to do the degrees of freedom. So here you can do TCDF negative infinity to negative 4.002 with this many degrees of freedom to get this number, okay? And then you still double it and you get approximately 0. Anyways, forgot to mention that. Just wanted to point that out. Thanks for listening, you guys. Love you all.